So how do you find limits without using tables or graphs?
You forgot the negative! So when you're trying to find the limit as x is approaching some number, you can use like graphs or tables, but you can also use equations and just plug in the number into the x and just get the limit. So like here, this is an easy one. You could just plug in the 3. That will equal 13. It's 3 plus 10 is 13. But it's not always that easy. Okay, so here is a harder one. So let's try just plugging in -2 for the x. It ends up just being 0 over 0, since you have 0 on the bottom. That's the indeterminate form of a limit, so you can't do that. You have to find the determinate form, and that 0 on the bottom is undefined. So you need to try a different way to solve this. So remember back to algebra, when you learn factoring, it actually does matter, and it is important.
Wait, I'm supposed to remember that?
And the first thing you might want to do is to try factoring, because it just usually works out nicely. And you see here, the x plus 2's cancel out. So now you have, now you see you can plug in the -2. So you'll have 4. Okay, so here's another one. And the first thing you try is just plugging in the 0. And that doesn't work. There's going to be 0 on the bottom. So usually when you see like a square root, you want to try multiplying by the conjugate. So you do that. Yeah. And then multiply all that out. And then a lot of the stuff is going to cancel, that's going to cancel, and the 49s will end up also canceling. Now that all that stuff canceled, you can see that these x's are going to cancel. Then so now I'm at the point where I've simplified it enough where I can plug in the x that it's approaching. So I'm doing that right now. Final answer is 2 over 21. Yes, Julia.
But what happens if it approaches infinity?
Hey guys, so for this problem, we're going to do a problem.
I don't even see the problem.
We're going to do the limit as x approaches infinity of a certain function. Okay? So we're going to start out by multiplying the entire expression by 1 over x to the 5th over 1 over x to the 5th. We do this because x to the 5th is the highest power. Okay? So now we can cancel some stuff. So for example, we have this. I'll put this over here. 3x squared over x to the fifth, and the limit. Always remember to never drop that symbol right there. Alright? Good. So then, you can picture this because 3 over x to the third, that's what it cancels down to. So limit as x approaches infinity of that. So you can picture it because it could be 3 over like 10, and then like 3 over 100, and then like 3 over 1 billion, and as you keep going, it just gets closer and closer to 0. So yeah. So this is actually going to cancel out and become 0 because of the rule I just explained. Also will this and this. And then the bottom is the same way. So you have 7x over x to the fifth. That's actually going to be 7 over x to the fourth, which is going to approach 0. And then you have the negative 8x to the fifth over x to the fifth. The x to the fifths actually cancel out. So you're left with negative 8 on the bottom. Of 0 over negative 8. And then the 1 over x to the fifth will then just like be the same as the top, so it's going to cancel out also. So then you're left with the limit as x approaches infinity of 0 over negative 8. Well, that's just going to be 0, because if you have 0 on the top, it's just going to equal 0. So the limit as x approaches infinity of the function is going to equal 0. Alright guys, so for this one, I'm going to teach you a little shortcut to limit equations as x approaches infinity. So for these ones, the only part that really matters is the coefficients of the highest power. So in this one we have the function of negative x to the fifth minus 2x plus 50 all over 4x to the fifth plus 8x squared minus 1. So based on the last problem, everything right here actually approached 0 because it had nothing to do with this highest power right here. So then we can just say the limit as x approaches infinity is negative x to the fifth over 4x to the fifth. But then you see that the x to the fifths actually cancel. So then you're left with the actual limit of the whole function equals negative 1/4. Because once again, x to the fifths cancel and you're left with negative 1 over 4.